All right, so let's first look at the first cycle, which is the tectonic cycle. So the Earth's upper layer, physically speaking, is a pretty dense and hard layer that is called the lithosphere. And we'll look at this in detail in the next chapter. But again, that upper layer, physically speaking, is called the lithosphere. So the lithosphere itself is made up from the crust, which is the uppermost chemical subdivision of the Earth, and a little bit below the crust from the uppermost part of the mantle, which is the second chemical subdivision layer with depth. So as you go deeper into the Earth. Okay, so there's a difference between chemical subdivision and physical subdivision, and that has to do with what things are made of for the chemical subdivision and how things are in terms of density, in terms of state, in terms of reflectance, all of those physical properties. That is how we divide physically speaking. Those things will make again more sense when we look at them in the next chapter. But again, the lithosphere, which is the first physically speaking layer, is made up from the uppermost chemical layer, the crust, and the uppermost part of a second layer, which is the mantle. Okay? So depending on where you are in the lithosphere itself is going to be a little bit thicker or a little bit thinner. It's typically thicker in continental areas, and it's going to be thinner in oceanic areas. And this has to do with specific densities and flow of the material itself. And again, I'll explain this in detail when we talk about plate tectonics in the next chapter. But for now, just knowing that the lithosphere and the crust itself are thicker in continental areas than in oceanic areas is good enough. So the lithosphere itself is broken up into many large chunks, if you would, which we call plates. So there are 7 major plates, several kind of intermediate plates, and there are a bunch of many smaller plates which make up some of those larger plates. So for example, here in this picture that you're seeing, each kind of subdivision marked by this blue areas or by the red areas, those are plates. Okay, so I'll go through them in a second. The biggest plate that we have is the Pacific plate. So that's over here as you're seeing it, and it wraps around towards the east part of the world over here. The other major plates that we have are the North American plate, which is pretty big, the South American plate, the Eurasian plate, which is also pretty huge, the Australian Indian plate, here they just call it the Australian plate, the Antarctic plate, I think that's it. I think those are 7, right? Yeah. And then the 7 intermediate plates that we have and are commonly spoken of, especially in this 101 or 104 classes, are the Juan de Fuca plate, which is actually rather small, but it is pretty important here in North America, so where it's talked about. So it's this tiny bit that you're seeing. Now, the Cocos plate, the Nazca plate right here, the Caribbean plate right here, the Philippines plate right here, and let's see, the Arabian plate, which is right here, not labeled, but it is right here. And then there are smaller ones. There are smaller ones as well, like the Scotia plate, which is down here, for example. Again, there are many subdivisions of each plate sometimes when we consider small motions. Okay, so all of these plates are rigid, they are solid, but they are sitting on top of what is a more plastic material. So this material, or this layer that they're sitting on top of, which is more plastic, that layer is called the asthenosphere. Okay, so the lithosphere is where the plates are, and then they're sitting on top of the asthenosphere, which is more plastic, more mobile. So you could think of the asthenosphere as slightly kind of like wet clay. So it's not fully liquid and it is not fully malleable, but it's definitely more mushy. And so the plates as slabs of rock that are sitting on top of the wet clay are going to move every now and then if there are changes at depth, for example. So each of these plates that is sitting on top of what we consider is the wet clay area or trying to move, they move in specific directions. So, and that is determined based on the deep underlying convection forces. And again, this is not something we are certain of just yet, but it's an ongoing hypothesis that convection, it's what is driving the motion of the plates going from one direction to another, and so on and so forth. Again, I will talk about this a little bit more in the next chapter. But the fact that these plates move in different directions causes some of the plates to move away from each other, like you're seeing over here. Some towards each other, like you're seeing, let me see some arrows. Well, it doesn't say, but these two are moving, oh, I guess here, one here, so these are moving towards each other. And some may slide past one another, like you're seeing, for example, here. Or it can be a combination of these three types of plate boundaries for one specific plate. So actually, for example, the Juan de Fuca plate has all of those three motions at different spots of the plate as it relates to other parts of the Pacific plate and the North American plate. So let's bring in some examples. Let's look at the South American plate. So again, that's over here in South America and covering a large part of the Western Atlantic Ocean. And we see that it is moving mostly to the west, as it is told to us by the arrow on the map. If we look at the African plate, which is just to the east of it, we see that the African plate is moving to the east, right? As is shown by the arrow that's on the plate. So this means that they are moving away from each other. And this type of boundary we called a divergent plate boundary. In this case, since both plates are moving away from each other, what's going to happen is that in the middle, there's going to be creation of more material. Something, which is typically some sort of volcanic material, is going to rise and occupy the space that is being created by these two plates moving away from one another. On the other side of South America, however, here on the west side, we have the Nazca plate that is going towards the east, and yet the South American plate is going towards the west. So we see that these two plates are pointing towards each other, or let's say are moving towards each other. And so this type of plate boundary we call a convergent plate boundary. Okay, so con typically means coming together. Di typically means going apart. So divergent would be this type of boundary where they're moving apart. Convergent where they're coming together. So yeah, that's what's happening on this side of South America, and that's why you get, for example, so many earthquakes and volcanoes in the Andes. And then the last type of plate boundary that we have is called a transform plate boundary, and that's when we have two plates sliding past one another. So a good example of that, and one that most of you are familiar with, is the one that happens in California right now, in Southern California, with the San Andreas Fault. So San Andreas Fault is a fault caused by the sideways movement of the North American plate from the Pacific plate. So as they're moving, sliding past one another, it causes friction, and it causes the amount of earthquakes and the movement that we see in Southern California due to that. So a set of events typically take place throughout the tectonic cycle. There is no specific number of years that are given for each of these events to occur, and they are highly dependent on the location where you're at in the world, on the plate boundary type that you're seeing, and on the interaction with the three other cycles. So in their interaction between the rock cycle, the hydrologic cycle, and the biogeochemical cycle. But typically, this set of events that occur is just an example of what could happen within the tectonic cycle. So to simplify things, I'm going to use this example again above. So in this example, the first step that we will look at is the deposition of sediment, right here. So the deposition of sediment can happen by the surface water at, for example, riverbanks, right? So as the river's flowing, it's leaving behind some sediments. It can also happen in deltas. So deltas are the mouth as the river is encountering the ocean. And it can also happen in the ocean itself, so further offshore as that water carries the sediment further. So as you're seeing here, these layers below, those are layers of sediment as it gets deposited. And some of the sediment is so fine and so easy for the water to carry that it will carry it even further and deposit it further offshore, for example. So once the sediment has been deposited, you need further burial and further compaction. So that would be our second event. So you get it deposited somewhere, and then you get it buried and compacted. So both of those things can happen from basically more sediment getting deposited on top of the first set of sediment that we considered. So by the same processes, same water flowing at the mouth or at the riverbanks or further offshore, you get further deposition of sediment, which makes the beginning or the earlier sediment get buried and hence be compacted. So compacted just means basically be squished, be put enough pressure so it starts getting packed, right? Okay. If that sediment, again, gets buried deep enough, it is easier for it to be subducted under a nearby convergent plate. So subduction means being placed underneath. So what this plate over here is doing is that it's being subducted under this plate over here. Okay, so the kind of yellow slab that you're seeing, that's a plate. Well, yellow, orange, and kind of brown. That's all one plate that is being subducted under this other plate over here on the left. Okay, so in our example, for example, if the sediment got deposited, it got deposited and further buried offshore quite a ways, let's say around here, and it is now part of this oceanic plate, right? This big slab. From the diagram, we can see that the oceanic plate appears to be going underneath that continental plate, right? So we see that it is going underneath, and we see that this is continental, this is oceanic. So if any sediment that was buried here, it will eventually start getting subducted under the continental plate. So in this type of boundary, when you have the subduction of the oceanic plate underneath the continental plate, we have what type of plate boundary? I'll let you think. So we have three possibilities: divergent, convergent, and transform. So hopefully you're thinking of convergent, right? Because they are coming towards one another. And because they're coming towards one another, one of them will have to give, or it will have to go underneath, and the other one will have to go over. We'll talk about specifics in the next chapter of how that is typically decided, but we will see that again in the next chapter. So with the further subduction of the oceanic plate, or again going under, the sediment that was originally here will eventually reach the margin, that is here, and then be subducted itself. So with this subduction, there usually comes some heat and some pressure that are applied because you are getting further into the earth, and with that comes a lot of heat, and we'll talk about that in the next few chapters, and a lot of pressure because things are more squished, things are more uncomfortable. So heat and pressure are common the further in depth that you get. Thanks again, the heat is going to be happening thanks to the geothermal gradient, and again I'll talk about that later. And also the pressure is going to come from gravity forces basically, but I will talk about them in detail in chapters 5 and 2 respectively. So with this great heat and pressure, amongst other smaller agents, there is a great possibility for the material to get deformed. And if too much heat and pressure are applied, it may even melt. So when it deforms, it can change. So it can go from just being, say, sediment that got compacted and perhaps made into a sedimentary rock. And if enough heat and pressure are applied, it could become a metamorphic rock. And if more heat and pressure are applied, then it will start melting. So that would be this next step over here.